Good morning, students. In the last unit, the unit 2, we studied about the structure of atom and how the atoms, subatomic particles present in the atoms, that is neutrons, protons, electrons, and the electronic configuration, quantum mechanics, model everything. In today's class, that is unit 3, we are going to study about the chemical bonding. So first thing is, what is chemical bond? What is the need? Why each and every element wants to form a chemical bond with other. For example, salt is there, that is NaCl. Na may stand separate and Cl may occur in separate, but instead of that, they combine with each other and they form NaCl. What is the reason for that? Listen, first I will say what is chemical bond. Okay. Chemical bond. So what is chemical bond means? It is a force of attraction which holds constituent particles together. Okay, so listen, it is a force of attraction which holds the constituent particles together is called as what? Chemical bond. Okay, why each and every atom wants to form a chemical bond or wants to hold the constituent particle with each other means that is reason for chemical bonding. So important students, those have to attain octet configuration. Octet configuration means noble gas configuration. Okay. Second one is they attain or to attain minimum energy and maximum stability. So this is the reason why each and every atom wants to form a chemical bond. One to attain octet configuration, another one to attain minimum energy and maximum stability. Okay. So what is octet configuration means? Octet means 8. Okay. So each and every atom, so noble gas configuration means that is NS2, NP6. Total 6 plus 2 means 8 electrons. So each and every atom wants to attain the 8 electron system. Understood? That is octet configuration. After bonding or before bonding. Okay. I'll explain what is this octet configuration and everything. So I'll give one example, student. Here, NaCl is there, you assume. Okay. NaCl means Na atom is atomic number 11, Cl atom is atomic number 17. If you write the configuration, that is 1s2, 2s2, 2p6, 3s1. Correct? For Cl, 1s2, 2s2, 2p6, 3s2, 3p5. Correct? So here, to attain next corresponding noble gas configuration, it has to get 7 electrons. Understood? Here 3s1 is there, next configuration is 3s2, 3p6. Understood? So here, this is a noble gas configuration of what? Neon. This is neon 3s1. So this one is neon 3s2, 3p6. The next successive noble gas is argon with atomic number 18. So students, here if it loses one electron means it attains noble gas configuration. If it accepts one electron means it attains noble gas configuration. Because its configuration is 3s2, 3p6, here 3p5 is there. To attain the nearest noble gas configuration, it requires one electron. To attain noble gas configuration, it has to lose one electron. So listen, if sodium is there, if you consider this outermost shell, total 8 electrons are there. Next, consider Cl here. If it accepts one electron, means it attains noble gas configuration. Either by sharing an electron or by transferring an electron or any other thing, each and every atom should attain 8 electron system. That is what? Octet configuration. So each and every atom wants to chemical bond with the other atom. Why? Because to form a chemical bond. Okay. So to attain octet configuration. Octet means 8 electron system around the atom. Next, to attain minimum energy and maximum stability. Once the atom becomes stable means, so it attains a minimum energy. It loses its energy. Understand? So when it loses its energy means it becomes completely stable. Understood? High energetic particle is unstable. Low energy particle is stable. You know, the unpaired electron is there, that is highly energetic and that is unstable. If paired electron is there, that is paired electron is a minimum amount of energy is there, so that means that is stable. Okay. So which one has the highest energy means that become unstable. Which one has the less energy, that is minimum energy means that become more stable. Okay, so to attain the maximum stability, they want to get bond with each other. So this is the chemical bond. Okay, so students, in this chemical bonding, the first thing is Lewis concept. First, we have to know the valence electron and the this octet configuration is explained by Lewis concept. Or it is also called as dotted structure. Okay, so I'll consider a set of elements here. Listen: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, so atomic number of lithium is, you are right, atomic number, that is that. Okay, for lithium it is 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if you write the electronic configuration, you will get electronic configuration, that is 1s2, 2s1, correct? That is helium 2s1. Then I get only 2s2, 2s2 2p1, 2s2 2p2, 2s2 2p3, 2s2 2p4, 2s2 2p5, and 2s2 2p6. This is completely filled configuration. Here, helium is the completely filled configuration. Assume this thing. Helium is the nearest. So these two electronic configurations start from 1s2. The next corresponding noble gas is neon 2s2 2p6. So listen students. Next one is we have to write the ionic charge. We have to write ionic charge or oxidation state, you may say. Ionic charge or oxidation state. Listen, here I told you each and every atom wants to attain noble gas configuration. Understood? So for helium, this is only doublet configuration, except helium, the next atom shows octet configuration. Okay, so here, listen, so this is 2s1. helium 1s2 2s1. So to become 2s2 2p6, it requires further 7 electrons. Here it is 2s1 means to become 2s2 2p6, it requires 7 extra electrons to attain near configuration. But if it loses only 1 electron, it attains helium configuration. So the students, the amount of energy required to remove 1 electron is favorable than the amount of energy released when 7 electron is added to it. Understood? So this one prefers loss of electron means, so loss of electron means that is plus 1 charge. Electron is minus, so 1 charge loss means that become plus 1. So here also same thing. To attain helium configuration, it requires 6 electrons. To attain helium, it has to lose 2 electrons. So it prefers loss of electron. Here also same thing, plus 3. But here in carbon, what happens? 4 is there. So to attain helium configuration also, it requires 4 electrons. To attain near configuration also, to attain helium configuration, we have to remove 4 electrons. To attain near configuration, we require 4 electrons. So that's why this may show plus or minus for oxidation state. Plus 4 or minus 4. It may lose 4 electrons and it may gain 4 electrons. So next, nitrogen, here already 5 electrons are there. So here to attain helium configuration, we have to remove 5 electrons. To attain this clear configuration, we have to add 3 electrons. So the energy required to remove 5 electrons is unfavorable compared to this addition of 3 electrons. So the addition of 3 electrons is easy. That's why addition of 3 electrons means extra 3 electrons. 3 electrons means with the minus charge. This is minus 3, minus 2, minus 1. This is 0. Okay, so this is the oxidation state students. Then, if we want to know the valency, so whether positive or negative, the number is the valency of the respective atoms. Here plus 1 means valency is 1. Here plus 2 means valency is 2. Plus 3 means valency is 3. Plus 4 plus or minus 4 means valency is 4. Again, the nitrogen minus 3 means valency 3, 2, 1, 0. Understood? This is monovalent, divalent, trivalent, tetravalent, again trivalent, divalent and monovalent and 0. Understood? So the valency of the noble gas configuration is 0 means they never react with other atoms. So what is this valency? If any atom combined with lithium means it has the capacity to form only one bond. Here beryllium means it has the capacity to form 2 bonds. Boron means it has the capacity to form 3 bonds. Similarly, carbon it has the capacity to form 4 bonds. Similarly, remaining elements also. Okay. So this is the valence electrons. Understood? So you may write the valency is this. Valence electron is this. In the valence shell, how many electrons are there? That gives the valence electrons. Okay, or a valency of the atoms. So how to write the Lewis concepts in the symbol of these elements in the Lewis concept means I write here lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. We have to choose valence electrons. So students here, consider the configuration. So here this is the valence electron or valence shell. So the number of electrons present in the valence shell shows what? The Lewis symbol. So listen, for lithium 2s1 means only 1 electron. For beryllium 2 means electron. For boron 3 means 3 electron. For carbon 4 electron. For nitrogen 5 electron. Correct? For oxygen 6 electrons. For fluorine 7 electrons, and for this neon 8 electrons. What is this? This valence shell electronic configuration. This is the way to write the Lewis concept. So this is all about the Lewis concept. This Lewis concept successfully explains the octet configuration. How many electrons required to make the bond? How many covalent bonds can form? How many ionic bonds can form? Whether the loss of electron takes place or transfer of electron takes place. Everything is explained by this Lewis concept and also valencies. You have to remember the valency, oxidation state, configuration, valence electron and the Lewis symbol. Understand? So this is all about the oxidation. Reason for chemical bonding, that is octet configuration, which is explained by Lewis concept. Okay. Next we will discuss about the types of bonds. Okay. So types of bonds are there. So many types are there. Covalent bond. Okay, and here. Covalent bond. Next, ionic, metallic, coordinate, and last, van der Waals force. Van der Waals force. So in that, you are going to study only covalent and ionic in this chapter. Okay. So many types are there: covalent, ionic, metallic, coordinate, and van der Waals force. In this van der Waals, hydrogen bond will come, dipole interaction will come, polar, non-polar will come. Okay. So we will study covalent and ionic bond. Okay. So the first one is ionic bond. So what is ionic bond? Dear students, I'll write the definition first. The bond formed by the complete transfer of electron from one atom to another. This will form what? Ionic bond. So I write the example here. So listen, sodium is there with atomic number 11. So its electronic configuration is 1s2, 2s2, 2p6, 3s1. Correct? Next, Cl is there. Its atomic number is 17. Then here 1s2, 2s2, 2p6, 3s2, 3p5. So here what happens, if you write the Lewis symbol for this. So this is a valence electron or a neon configuration. Am I right here, students? This is neon configuration. If it attain means it has become 3s0, or you may take 3s1. So this one is 3p5. The next is argon. Correct? So here we have to check whether each and every atom should attain what? Noble gas configuration. Correct? So it loses one electron as I told. It loses one electron means atomic number 11 means protons also 11, electrons also 11. Electrons also 3. Correct? So here in neon 3s1 is there. To attain this neon configuration, it loses one electron. Then what happens? It becomes neon 3s0. So one electron less means then what happens? Protons becomes 11, electrons become 10. Proton charge is plus, electron charge is minus, remaining is plus 1 charge. So this is Na plus. Correct? Next here, if it loses electron, means here what happens? 3s to 3p5 is there. Next Noble gas configuration is 3s to 3p6. So what it will do? It gains an electron. So then it forms argon configuration. How? So it becomes p6. That means argon configuration. Here, protons are 17. Electrons are one extra electron means 18. So this is plus charge, this is minus charge means minus 1 will left. Then this becomes Cl minus. Okay. So how the bond will take place? So listen. Here Na is there. It attains noble gas configuration. So Cl is there. It attains. It has one electron less. So this is what? One set. Okay. 2s2, 2p6 it is. One extra electron are also here, that is 3s1. So here this is 3s2, 3p5. Correct? One electron is less here. Then what happens? The extra electron from sodium is completely transferred to this Cl. So then what happens? The loss of electron takes place here and gain of electron takes place here. This is the electron from what? Sodium. Okay. So here also it satisfies 8 electron system. Here also it satisfies 8 electron system. Here loss of electron takes place. Here gain of electron takes place. So which one is the plus charge? That is called as cation. The species with the minus charge is called as anion. Okay. So in ionic bond they form cations and anions. And both cations and anions combine to an ionic bond. Become NaCl. So this is the ionic bond. Understand? This is the way to form an ionic bond like this. Mg you may write, PaCl2 you may write, okay, LiCl, AlCl3, okay, whatever the way you write, you get the same ionic bond. Understood? So up to group number 1, 2, and also 15, 16, 17 group elements forms ionic bonds. And these are cations and these are anions. Understood? And also the valences depends on that. This is about the ionic bond. So next we will discuss covalent. Next one is covalent bond. So definition, the bond by the sharing of an electron between two atoms. Okay. So here bond formed by what? Sharing of an electron. Sharing of an electron or electrons between the two atoms. Initially I required complete transfer of electron. Here only sharing of electron. So here students, this covalent bond is formed by the complete sharing of an electron. In these there are types of bonds are there. Single bond is also there. If one electron is shared between two atoms, okay, double bond is also there, triple bond is also there. So there is single bond, double bond and triple bond. Okay, I'll give the example here student. For example, hydrogen is there. Hydrogen, assume fluorine. Fluorine is there, atomic number is 9, that is 1s2, 2s2, 2p5 configuration. Correct? So, take two fluorine atoms here, write the valence electrons here. Each fluorine atom has 5, 6, 7 valence electrons. So then, the first thing is each and every atom attains octet configuration when they get bonded. So here, consider this the sharing pair of electrons. It becomes octet configuration. Consider this, it will become octet configuration. Here what happens? The electron from this fluorine and this fluorine share between each other and form a bond. Understood? So then including this 2, 4, 6, 8, it attains 8 electron system. Here also 2, 4, 6, 8, it attains 8 electron system. Then the bond is F single bond F. So this is the single bond. This is a covalent bond because the bond is formed by the sharing of an electron. Okay. So next we take oxygen. So atomic number of oxygen is 8. Configuration is 1s2, 2s2, 2p4. Okay. So here you consider one oxygen atom. So it has. So you consider two oxygen atoms. It has valence electrons. 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. Initially you consider these two electrons. Okay, when the bond takes place, students, initially you consider this, then it forms what? 2, 4, 6, 7, 2, 4, so 2, 4, 6, 7 electrons. So again, one electron is less to attain noble gas configuration. Then again consider this. Then this oxygen, after forming a single bond, here it is. Okay, it forms single bond means here one electron, it attains 2, 4, 6, 7 electron system. Then again remove these two electrons and form a bond here. Understand? So when you consider that, then it will become 2, 4, 6, 8 for this and 2, 4, 6, 8 for this. Including the bonded electron, they attain octet configuration. So the structure is O double bond O. So this is double bonded system. Okay. So similarly, if you take nitrogen molecule, that is N2. So atomic number of nitrogen is 7. Configuration is 1s2, 2s2, 2p3. Understand? So consider nitrogen here. both the nitrogen has 5 valence electrons. So if you consider the bond of 1 electron, then in time it becomes 6, 6. So still we want extra electron, means again you do by removing these 2 electrons. Okay, these 2 electrons, it will form double bond. Okay, here what we did, we remove this electron and we conduct bond. So this is 2, 4, 6, 7. So then this become 7, 7. Okay, so then again we require one extra electron to attain noble gas configuration, means again we will remove these 2 electrons to form another bond. Then it will form a 3 bond. Okay, so then you consider this, then it will form 2, 4, 6, 8, 2, 4, 6, 8, including the shared paired electron, then it becomes N triple bond N. So that is a triple bonded compound. Understand? So the covalent bond is the bond formed by the sharing of an electrons between 2 atoms. Here the sharing of electrons takes place. Why only I consider the homoatomic? Both are fluorine here, both are oxygen here, both are nitrogen here. They are homoatomic. Understood? So in this covalent bond, polar and non-polar type is there. How this non-polar and polar classifies, I will explain next. So listen, this is the way. Understood? So oxygen is there. It form one bond, means it attains 7-7 configuration. To attain octet configuration, we require one more extra bond. So it form double bond. Similarly for nitrogen, this is the way how the covalent bond takes place, by the shading of the atoms. Okay. So in the covalent bond, students, again in the single, double and triple bond, another types of bonds are there. One is polar, another one is non-polar. One is non-polar, another one is polar. See, if bond is formed between same atoms, then they are polar, like H2, N2, Cl2, F2, O2, etc. If the bond is formed between different atoms, then they are non-polar. That is HCl. Example, HCl. Okay. Next, HF. Next, CH4, CCl4, etc. Okay. If the bond is formed between 2 different atoms, then it is a polar bond. If the bond is formed between the same atoms, then it is a non-polar bond. So this is a type of the covalent bond. Okay. So the next one you have to remember is how to write the name of the compounds or salts you will say. How to write the name of the compounds. Name and formula you will take. So formula, whether it is a formula, whether it is a name, students, cation should name first. Rules to write name of compounds. For example, NaCl. So here, this is plus charge, this is minus charge, correct? Always the cation name first. Cation followed by anion. Remember this, cation followed by anion. This is the way to write the name. So cations always ends with IUN. Anions always ends with IDE. Okay, so the name of the cation here is sodium. So this one is chloride. Okay, if I take LiCl, so this one is lithium, this one is chloride. If you take Mgs, this is magnesium, this one is sulfide. Understand? So always the cation ends with IUM and this anion ends with IDE. This is the way to write the name of the atoms. Understood? Similarly, to take AlCl3 means that is aluminium chloride. Okay, so this is the way to write the name of the first cation name first, followed by the anions. No matter whether it is a simple salt, complex salt, or a coordination compound or a double salt, always the rules is to write the cation first, followed by the anion. Okay, if you want to write the formula also, students, so listen, if they give aluminium sulfate, then you have to write aluminium first, sulfate next. Okay, how to write the formula? So listen, aluminium is with the +3 charge, this one is with the -2 charge. Cross multiply these two, you will get Al2SO4 thrice. I'll explain how to write the formula. So this is how to write the name. Then how to write the formula is, you should know the oxidation state of the respective atoms. For example, listen here. Sodium chloride again. Sodium means Na plus Cl minus. So this is +1, this is -1. If you cross multiply, you will get NaCl, that is sodium chloride. If they give magnesium chloride, okay, so Mg means you should know the oxidation state of Mg, that is +2, Cl is -1. Write the numbers here, this is 2, this is 1. If you cross multiply, you will get MgCl2. Understand? Similarly, if they give sodium sulfate, so sodium is Na plus, sulfate is SO4 2 minus. So here this is 1, here this is 2. If you cross multiply, you will get Na2SO4. Understand? So another, they may give aluminium nitride. Okay, so Al is +3 charge, N is -3 charge. So here it is 3, 3. This may be divided by 1 means 3 ones are 3 ones are. This is Al. N. Understand? So this is the way to write the formula of the compound. If the formula of the compound they given, if Na2SO4 they given, this is sodium, this is sulfate, this is aluminium nitrate, this is magnesium chloride. If they give the name, you have to write the formula by cross multiplying the oxidation states of the valencies of the respective atoms. Okay, so this is all about the chemical bonding. Thank you.